Chapter 2 is about economic models. And economic models are simplified representations of reality. Good. Okay. So in economics, models will be graphs, and the graphs are going to show simple representations of reality. And what that means is it's going to show relationships between two economic variables, such as the price of something and the quantity that people want to buy. Now, when we represent this relationship, we will have to hold all other variables constant so that we can just focus on the relationship between these two variables and not have any other variables confusing the situation. Okay, so this is called the all other things equal assumption. Or, this is the Latin phrase that means the same thing, ceteris paribus. Okay, so for example, what if the price of a good changes? Now we can predict that when the price of the good changes, it will change the amount that people want to buy of the good. But we have to assume that other things for the consumer have not changed, because other things will influence how much a person will buy. But if you let too many things change at once, then it becomes confusing. So for example, if the price goes down for a good, at the same time a consumer's income has gone up, then they will buy more of the good, but we won't know why. Was it that they buy more because their income went up, or did they buy more because the price went down? So what we do instead is we say, okay, if the consumer has this fixed amount of income and the price goes down, we will observe how much more they buy of the good, and we know for sure that they bought more of the good because the price went down. Okay, so we have to control for these other variables, such as person's income, preferences, or availability of other products. Okay, now in this chapter, we're going to start by talking about production. And the first model is called the production possibility curve, or production possibility frontier. So this is going to show for a person or an economy what is possible for them to produce. Now we know that everybody has scarce resources, and so because resources are scarce, the possibilities for production are limited. Okay, so this graph illustrates the quantity of production that is possible in an economy or for a person. Okay, so resources are scarce. Okay, so for example, suppose you have these ingredients, and with these ingredients, you could make cookies or a cake, but you don't have enough for both. And so because of that, because the resources are scarce, you have to decide to make one or the other, and that is a trade-off. So we must make trade-offs in production. And trade-offs is a word from chapter 1. You'll probably remember that. So that's when you choose one thing, but you give up something else. Okay, so this model is going to illustrate that first principle from chapter 1, that resources are scarce. Now we're going to switch to another example where we have a small economy on an island, and the only two things that they will produce are coconuts and fish. And they just have some limited simple materials for resources, time, land, labor. Okay, so what this model or graph will illustrate is what is possible for them to produce. So if they use all the resources, for example, just to catch fish, it'll show the maximum number of fish they could catch, Or using the same resources, if they use all of the resources to only pick coconuts, the graph will show the maximum number of coconuts that they could pick. Okay, so the model will show the maximum number of coconuts or fish. But of course, they don't have to just catch fish or just pick coconuts. They could have some of each. And so they could have many different possible combinations for production. They could produce a little bit of fish, more coconuts, or just a few coconuts and lots of fish, or half and half. You know, lots of different combinations. And the graph will show all of these different combinations. Okay, so here we have a table, and then we're going to draw the graph. The table, looking at the table first, we have the different numbers of combinations of coconuts and fish that can be produced. All right, and so what you want to do is just plot these points over on the graph. Okay, so 70 coconuts, 0 fish, 60 coconuts, 20 fish, 45 coconuts, 35 fish, 25 coconuts, 45 fish, and finally 50 fish with 0 coconuts. Okay, so this is the production possibility frontier. So I'll just label it PPF. Okay, so it's showing the limit to what the economy can produce. If the economy tried to produce, say, a combination out here, 50 coconuts and 50 fish, that would not be possible. They don't have enough resources. So any point outside of the curve is not possible. This is the maximum or the limit to what they can produce. If they produce something inside the curve, let's say here 30 coconuts and 20 fish, they could do that, but it wouldn't be efficient because it would mean that they were giving up the opportunity to produce more of the goods. So starting at this point, they could produce more coconuts, or they could produce more fish, or if they went from here, say to this point, that would give them more of both goods. Okay, so anything inside the curve is going to be inefficient. All the points on the curve are therefore possible and efficient, right? So all the points. Okay, so again, this curve illustrates that first principle from chapter 1, that resources are scarce. It also illustrates the idea of opportunity costs or trade-offs, because for the economy, if they want to produce more of one good, they have to give up production of the other good. So let's say the economy is at this point here, and then they want to produce more fish. And so that's going to require them to move to this point here. The only way to do that is to give up some coconuts. Okay, so they would have to give up coconuts in order to get the extra fish. So the number of coconuts they would have to give up is 20, right? They're going from 45 to 25. And then they would get 10 fish, right? From 35 to 45 fish. Okay, so the curve illustrates the opportunity cost. And you'll notice that this opportunity cost would be measured by the slope of the curve, right? The difference in the vertical variable relative to the difference in the horizontal variable. Okay, so on the next page is a definition for the production possibility curve. all possible combinations of goods that can be produced, assuming that, so we're going to assume that all the resources are used, right? They're being efficient. And technology and resources are fixed. So we have to assume that, because if technology improves or the economy gets more resources, then it's going to expand their production possibilities. Okay, so we'll talk about that in a few pages, but for now we're going to assume that those two things are fixed. Okay, the next things we've already talked about. So points outside the curve are not possible because there's not enough resources. Points inside the curve are inefficient because they're giving up opportunities to have more of the goods. And therefore, points that form the curve are efficient. And then opportunity cost. So the amount of one good that has to be given up to make more of the other is called the opportunity cost of additional production. Okay, so now we're going to do a couple calculations of opportunity costs. So first, if the above economy is producing 45 coconuts and 35 fish, the opportunity cost of producing 15 more coconuts is, okay, so let's go back to the table. Good. Okay, so if the economy is at this point and they want to produce 15 more coconuts, they will have to give up, that is a loss of 15 fish. Okay, so 15 fish is the cost of 15 coconuts. And you can simplify that. 15 for 15, that would be 1 for 1. So 1 fish per coconut. Okay, so for the 15 coconuts, the cost is 15 fish or 1 fish per coconut. Okay, one more example. If the economy is producing 25 coconuts and 45 fish, the opportunity cost of 5 more fish is. Okay, so let's go back to the table. Okay, so now they are at this point. They're starting at this point and they want to produce 5 more fish. So it looks like they will have to give up all of those 25 coconuts. So the cost of the 5 fish is 25 coconuts. And again, you can simplify that then. So the cost of the 5 fish is 25 coconuts, or that would work out to 5 coconuts per fish. Okay, so the general formula for calculating an opportunity cost is how much is lost. So delta lost means the change in what you're losing, so the quantity that is lost, relative to the quantity of the good that you're gaining. Okay, so on the next page, we're going to go through the full table, calculate the opportunity cost between each different point.
Okay, I'll just put the table underneath so that we can look at both of them. And I need a pen. Good. Okay, so we'll start with fish, so opportunity cost per fish. So starting at 0, they increase production of fish to 20, but they would have to give up 10 coconuts. So using the formula that we talked about, I can find it. Oh, my pages, there we go. So here's our formula here. When we calculate opportunity cost, we're calculating what we lose, so the quantity, the change in the amount of what we're losing relative to the increase in the quantity of what we're gaining. All right, so 0 to 20 fish, but we give up 10 coconuts, so what we lose is on the top, so 10 coconuts over 20 fish. All right, so then we can simplify that. That would be 0.5 of coconut per fish. Next one, going from here to here, they would get 15 more fish. They would have to give up 15 coconuts, 60 to 45. So that would be 15 coconuts given up for 15 fish, or 1 coconut per fish. Okay, then next one, you get 10 more fish, 45 to 25 for coconuts though, so they would give up 20 coconuts. So 20 coconuts over 10 fish, or 2 coconuts per fish. Okay, last one, and this one actually, we did this one last class already. You get 5 fish, you give up 25 coconuts. Okay, now the opportunity costs there are increasing. As the economy tries to produce more and more fish, the cost will increase. So this is generally what will happen whenever we try to do anything. The costs will increase as we try to do more and more of it. And why is that? Well, we always try to start with the least costly things. So, right, so if we're going to give things up, it makes sense to start with the least costly things. But then if you want to give even more up because you're trying to do more of the activity and you've already used the least costly way to do it, now you have to start using ways to do it or resources that are more and more costly. So for example, when you guys study, if you decide to just study for say 1 hour today, you're going to think, okay, what's my schedule? What would be the easiest hour? Like what would be the most convenient hour? Or in other words, what would be the least costly hour for me to study today? Of course, right? That's what you're going to start with. But then if you wanted to study for a second hour or a third hour, well, you've already used the most convenient hour. Now you're going to have to use time that is less convenient and more costly to you, because that would mean you're going to give up more things, right? So you'd have more of an opportunity cost. Okay, so we choose, when we start production of something, we choose to start with the least costly resources. And then, as we try to produce more, we're then going to have to use resources that are more costly. The other way of saying that is that we start with the most productive resources. So another way of thinking about it when you're just trying to decide when to study, another way to think about it is, okay, I want to study chapter 1 today. When will I be most productive? Now, for a lot of people, say that's in the morning, right? You feel better in the morning, you're like, your brain is fresher, you've just had coffee. And so that's what you'll choose. You say, okay, I'm going to study chapter 1 in the morning because then I will be the fastest. And if I leave it till like 10 o'clock tonight when I'm really tired, then it's going to just take me that much longer to study the chapter. So no, I should study this morning because it will be the least costly time for me to study. Now, in this example with the fish, if you have an economy of people or an island with the people on, and the people decide they want to catch fish, when they start with the 0 fish and then they move to the next point where they then have 20 fish, what they would be doing is they would be saying, who's the best fish catchers? Let's have those people go and catch the fish. And because those are the best fish catchers, they would be the fastest. And because they're faster, then they would only have to give up 10 coconuts because they're fast. They don't have to give up much coconut picking time. But then when they move to the next point with 35 fish, they've already used the fastest fish catchers. So now for these extra fish, they're going to have to then use people who are not quite as fast. So then they have to give up more coconut picking time. So they have to give up 15 coconuts. And then if they want even more fish, now they've already used the best fish catchers and they've already used the second best fish catchers. So now they'll have to use the third best fish catchers who are slower, and so on. And so then in the last for the last 5 fish, now they're using the worst fish catchers who are just super bad at it and they're super slow, and so therefore they're giving up a lot of coconuts because they're having to give up so much coconut picking time. Okay, all right. Any questions? All right, let's do the next column then. So opportunity cost per coconut. So now we're going to start at the bottom here and go up. So starting with only fish. Then they decide, let's have some coconuts. Okay, so they're going to get 25 coconuts, but they would give up 5 fish. So we're going up the table now. So they give up 5 fish. So now we put that on the top. And then what they would get is 25 coconuts. Now notice that it is simply the reciprocal of this opportunity cost because we're going the other direction. So it's just the reciprocal of this fraction here. Okay, so we can simplify that. Let's say 0.2 fish per coconut. Okay, next point, we will get 20 more coconuts from 25 to 45. We get 20 coconuts, give up 10 fish, 45 to 35. Okay, so 10 fish goes on the top, 20 coconuts, so a half a fish per coconut. Next, we will get 15 coconuts, but giving up 15 fish. So 15 fish for 15 coconuts, or 1 fish per coconut. Okay, and last one, we get 10 coconuts, but we give up 20 fish. So 20 fish for 10 coconuts, that will be 2 fish per coconut. Good. All right. Okay, so now filling in the notes. Oops. Like that. There we go. Okay, so the notes here are about what I was just talking about. Why do the opportunity costs increase as you try to produce more? And so the idea is that you start your production with the most productive resources, or you could say the least costly, because least costly, it is least costly when it is the most productive. Okay, so in this example, it would be starting fish production with the best, fastest fish catchers, and because they're fastest, they are least costly because that means they don't give up as much coconut picking time. All right, okay, so then fewer resources are needed. So for example, less time, and then that will result in a smaller cost. All right, and then as you try to produce more, then you have to use the resources that are not as good, they're less productive. More resources are needed then because those resources are less productive, so that will cost more. Okay, now this idea of an increasing opportunity cost we can see illustrated in the graph. Okay, so the slopes that we just calculated, first, so for increasing fish production, so starting up here with 0 fish, and then moving to the next point was here, the slope was 10 over 20, or 0.5 coconuts per fish. And then the next point was here, and so the slope there was 15 over 15, or 1 coconut per fish. And then let's see, the next point was, yeah, that's right there. Okay, and so that was a change of 20 over 10, or 2 coconuts per fish. And then the last one from here to here, that was 25 over 5, or 5 coconuts per fish. Okay, so these opportunity costs that we just calculated in the table are the slopes then between the different points. And so because the opportunity cost is increasing, the slope is increasing. So it's not a straight line. It is a function or a curve that we could say is bowed out, or we could say it's concave to the origin. And anyway, it's not a straight line. And it's not a straight line because the opportunity costs are changing. And the opportunity costs are changing because the resources are not all exactly the same, right? The people are not all exactly the same. They have different skill sets. You start with the most skilled people, you have the least cost, but then you have to use people who are less skilled, less skilled, less skilled, and so then your costs will keep increasing, and then you get this curve shape instead of a straight line. Okay. It's always nice pause. There we go. Okay. All right, so next sentence then. The opportunity cost is the increasing slope of the PPF. And so then we can say that the curve is concave to the origin. Concave to the origin. Or, like in math, you would say it's the function is decreasing at an increasing rate. All right, any questions? Good. Okay, now for economic growth. So let's go back to the definition for a PPF. That was something you wrote down last class. It was at the top of page 2. Let's just look at it again here. Okay, so the definition: production possibility frontier, it shows all the combinations that are possible to produce, assuming that, so we have two assumptions here. Number one, all resources are used and technology and resources are fixed. Now, that last assumption there, technology and resources are fixed. That is because what will happen if, for example, the economy gets more resources, like more labor? What would happen to all the numbers? They'll all increase, right? Or if they got better technology that allowed them to produce quicker, then all the numbers would increase. Yeah, so if all the numbers increase, what's going to happen to that line? It's going to shift out, that's right. So we have to say that for this line, technology and resources are fixed. But if those change, we will get a new line. Okay, so we'll get a new line. And so that would be economic growth if it's moving outwards. There we go. Okay, so economies grow when an economy either acquires more resources or develops better technology. So here's some examples. First one, Tom finds a stick. Tom finds a stick. Okay, so this will increase his ability to get coconuts or fish, because with a stick you can hit coconuts or hit fish. Anyway, so the quantity of coconuts would increase and the quantity of fish would increase, and so you get a shift of the curve out that way. Next one, Tom finds a new fishing pond. Okay, so obviously that is not going to change coconut production. Coconut production will stay the same, but it will increase fish production. So this would be what we call a rotation of the curve, where all the points are moving to the right, but not up. So when you draw a rotation, you have to be careful not to draw it moving up at all, just to the right. Economies can shrink if, okay, so the opposite, now technology will probably never go backwards, but definitely resources could decrease. So economies can shrink if there is a decrease in resources. First example, Tom gets sick and cannot work as much as usual. So now there'll be a decrease in the amount of labor. So that will decrease coconut production and it will decrease fish production, so the curve would shift inwards. Some coconut trees blow over in a hurricane. Okay, now this one you can actually think about it two ways. So maybe in the short term, they would have more coconuts because now they're on the ground and they can reach them easier. But in the long term, obviously then they'll have less coconuts. So we'll draw it thinking in the long term. Okay, so in the long term, they will have less coconuts, but no effect on fish. So this will be a rotation downwards then. All right. So last thing for this part of the chapter is a little bit more about the idea of efficiency. So efficiency means that we have made people as well off as possible. But we can think about efficiency in an economy in a couple different ways. First of all, we can think about it in terms of production. Are we using all the resources to produce as much as possible? But then we can also think about it in terms of trying to maximize the satisfaction of the people in the economy, which isn't just about having as much stuff as possible. It's about having the kind of stuff that people most want. right? So we don't want to say maximize production of typewriters because nobody wants typewriters. What we want to produce is the maximum of the things that make people the happiest or give people the most satisfaction. Okay, so these two ideas of efficiency are productive efficiency and consumption efficiency. So productive efficiency just means that you or the economy is producing at a point on the PPF, which means they're using all their resources to produce as much as possible. To know about what would be efficient for consumption, you would need more information about the people's preferences. So here we're told consumers prefer B. Okay, well then they should produce at point B and not produce at point A. Okay, so only B is consumption efficient.